Hello friends, welcome to next blog in Drag Gen AI series. This blog series is for beginners and young entrepreneurs who want to get started and build RAG-based Gen AI applications. In the very first blog, I've shown you the use cases, what we are going to build in this series, and in the second blog, you see how to quickly get started with the RAG Gen AI. You can find this video in highlight section in my X handle, ashokalax, and also you can find the same videos on my YouTube channel. Now, if you like this content, please consider subscribing to my YouTube channel and follow me at a GitHub and X account. Today's blog is going to be the most interesting and important one. Today, we are going to reset up Ollama, learn how to chat Ollama with the latest llama 3.2 model, and we are going to use Ollama to download PDF, CSV, and create a local dataset. And later, we will learn about creating tokens and embeddings from this data. And just to reiterate, we are going to use the top latest model available as of now, which are open source. So for example, using TryChroma or SQLLite kind of a thing with llama 3.2, which is 100% locally hosted on API running locally on your machine. And once we set up this open source technology on our machine, then later on we are going to create RAG databases, creating embedding on tokens, etc. And we are going to build pro application on top of this. All right, so let's get started. First thing you will need an AI code editor. It's not mandatory. You can also live with VS Code, but I highly recommend using Cursor AI if you have that. Otherwise, if not, just you download the VS Code. Next set of tool, obviously you will need Python. So go head out to python.org and download the latest version of Python. In this case, latest as of now, as of today, is Python 3.12.6. So let's open a command shop terminal window inside the cursor editor. As you can see, this is a PowerShell. Let's issue a command, say Python version. It may fail because your PowerShell, the Windows PowerShell, it only understands Py version. So if you say Python-version, it will say Python not found. Now if I try Python 3 version, all right, let's try that Python 3 -- version. So it tells you that it's not found. So most of the new OS version of Microsoft, they work with Py. So just say Py -- version. And as you can see, it finds the Python. Doesn't matter, one way or another, you should have Python installation. That's all it matters. Now let's go to our Ubuntu machine here. Same thing, you can type a command, first say uname. So it tells me that this is a Linux machine. Second, you want to say Python version, or just say which Python, and it will tell you which Python is installed on your machine. So as you can see, I do not have a Python. Instead, I have a Python 3. So which Python 3? Now, if you end up installing your own Python version, and Windows, simply you can change the environment variable. In Linux, what you want to do, you open your bash rc file in VI editor and include that path of the latest Python version you have in your machine. So that way, what you can do, you can run your own version of Python in case if you want to do that. All right, so that's it, pretty much it. Looks like we already have a successful Python installation. That's the most basic thing what you need to get started. Next set of tool you will need is Ollama. So Ollama basically is just you can think about it as a framework which helps you run LLM models, open source LLM models on your machine. So go to ollama.com, and if you're on Linux machine, run that command in your Linux window. And if you're Windows machine, just download the exe version and double click on it. All right. So it's a very simple installation, just double click on it. And at this point, I assume that you already have double clicked on it and you have Ollama running. In case if you get in trouble and if you want to know more about it, I have posted 2 different videos on this similar topic. So please reach out to and go through those videos. Now let's go, once you have that Ollama running, next thing, go back to your PowerShell window and type Ollama list. So what this command does, it will tell you all the available LLM models running on your machine. Same thing, if you want to specify, if you want to remove a model, say llama 3.2, which you don't like it, you can just say Ollama rm, that means remove, give the model name. It will remove that. And if you want to install that, simply issue the command saying Ollama pull llama 3.2. And same command runs, you can run it on Windows machine. So again, if you're interested in some particular models here, go back to ollama.com, and here you can see there are different types of models. So let's go install some coding model here. So if you type code, so as you can see, codegemma is the most popular model here, and there's a newer model for code generation is codellama. So let's install this codellama here. It may take few seconds to finish up. Once this is finished, let's try running a model here. So Ollama run llama 3.2. Once you issue the command, depending on your machine configuration, it may takes few seconds to warm up. And once this is done, you'll be able to execute your query. All right, so as you can see, send a message here. I'm just going to type something, say, what is the capital of Mexico? Mexico, okay. Let's see. Again, llama 3.2 model is smaller in size, but is very capable. So as you can see, it's very accurate. So while we're here, let's go test out our code generator model here. So Ollama run codellama. And once it loads, you can write a code related question. So for example, help me write a function how to add two numbers here. So let's just go draft our prompt. So help me write a function to calculate two numbers. And this is actually very, very bad prompt. So here I'm not even saying what kind of calculation I want. So let's see what it does. So basically the point is, if you give a smarter prompt, like if you write it appropriately, it will give good results. But here, as you can see, even I have given as a poorly written prompt, it just assumed that you are talking about you want to know that how to calculate sum and the product of two given number. And another thing, it assumed that you are asking for a JavaScript function. I would have wanted to see a Python function, but it did just assume that, okay, JavaScript by default, you are asking a JavaScript question here. All right, so that's all. Like now we have a successful Ollama running our machine, which can generate the code and which can also generate the LLM model. But what is our objective? We wanted to create a manually file. So our objective is to create an online manual based on the documents here. That's exactly what we want to achieve. So now let's start working on that project. First thing I want to do, I'm starting with a blank slate here. So we have a successful Python installation. Now let's go create a virtual environment. So any project you are working on, I highly recommend you please create a new virtual environment dedicated to that particular work, whatever you're doing. So as you can see, python-mvnv manually file. What this command is going to do, it will create a separate folder. And if you browse through that folder, that you will see that is a separate kind of a Python environment dedicated for that project. And you will see a couple of folders there include library scripts. And now you will need to activate your virtual environment what you just created. And how do you do that? You just need to issue a command saying script activate, and this activate.batch file is going to change your terminal prompt and is going to activate that virtual environment what you just created. Now you're inside your virtual environment. Now let's see what kind of packages you have. So if you say pip show list, is going to show you nothing. That means there's no packages installed yet. So let's go install a couple of packages here. Pip install pandas, and we also need Ollama. So pip install pandas and Ollama, and again depending on it will take a couple of seconds to load those packages here. Once those is done, let me clear the screen again one more time, and just let's say pip show list. So this will show you I think this is a bad command, so let's say pip list. Sorry about that. Pip list. All right, now it will show you all the packages already installed in your machine. As you can see, Ollama is one of that, which has just been installed. Let's clear this one more time. Next thing you will need a Jupyter plugin on your VS Code or as well as on the cursor. So let's go head out and to your extension here. Okay, click on the extension tab, and here you type Jupyter. So you will find a plugin called Jupyter. Please make sure that you have installed it in your machine. Otherwise, you won't be able to run your Jupyter notebook inside your VS Code or cursor. All right, so I already have that. I'm not going to do that again. Let's hit Ctrl-Shift-P and open a new Jupyter notebook. So by default, as you can see, it's going to create an IPYNB file. And first thing you want to do, you want to change the kernel and select the Python environment what you just created. Now here you can issue the same terminal command what you are issuing it in the terminal window. So if you just say pip list and make sure that your command is prefixed by an exclamation point, you'll be able to execute command shell prompt inside your Jupyter notebook. If you want to know about your one package installation, you can issue the command saying pip show Ollama. So it will tell you exact version of Ollama installed on your virtual environment. So I'm going to clear the cell output now. Now let's start using Ollama inside your Jupyter notebook. So say import Ollama, and next thing you want to do, say response request to ollama.chat. Now chat is a method or a function available on Ollama class. So please take a minute to understand what are the different parameters available for this chat window. As you can see, there's a model, messages, tool, and we'll cover everything in later section. But for now, let's go start with the model. So here I want to access the model, say llama3.2. And I want to pass a message. So as you can see, message expects two different JSON parameters, role and the content. Role is, you are just telling Llama model that what kind of, role you are expecting, a user or assistant, something like it. And the same thing, content is where you actually ask the actual question. So let's go ask this, how do you make sure that we have something running successfully? Let's go run this thing. So depending on your machine configuration, again, first time, it may take some time. So for me, it took me half a minute. That's not bad. So now it returned a response object. So if you see the signature of the response object returned, so as you can see, the response returned by Ollama, it has multiple things, done reason, total duration, and we are going to use these things later in later section. These are very important section here. For now, I'm only interested what is the actual result returning. But this is the whole set of JSON objects is written by the Ollama. So for now, let's just go focus on the message, and inside the message, as you can see, the content. So because we just want to know the answer of this particular question. So as you can see, if you say response, message, and content, it will just tell you the answer what you need to know. Now it's kind of inconvenient to every time create this function when you want to know something. So let's go create a generic function. So here, as you can see, I'm creating a generic function called getCompletion. So instead of hard coding the question directly into this one, I'm going to create some dynamic variable. So for example, data. We just say, hey, here is some supporting data, and we create another variable called prompt. So prompt is like, where you actually your actual question is. So for example, let's copy paste the same question here and put this as a prompt. So the whole thing what we are trying to do, instead of hard coding this data and prompt inside that Ollama chat interface, we are just creating a dynamic function, and we are going to pass this as a dynamic parameters here. So instead of like just putting, say, in the content you say based on this data answer this prompt, and now they take the data string here and make it as a dynamic parameter here. And the way to do that, as you can see, data, just wrap it around curly braces, data, wrap it around curly braces. Same thing goes with the prompt. So now what you have created a dynamic function which takes the couple of parameters and answers the question based on the questions you ask. So you can, the whole objective is the whole advantage of using these kind of methods and functions are so that you can use this over and over again. All right, so as you can see, let's define this function, and now what you can do in the next section, you're not going to touch it over again, and we are just simply going to call this function and we'll pass the prompt value here. All right, so let's just go run this one more time, make sure that function is created. Now let's go define data and prompt and run this, and I believe it's going to return the same set of results here. So let me get rid of data and prompt from there, and we are going to move it to the later section and make it more dynamic. Now, if you're wondering why I did that, so the whole point of RAG is the data is something which you retrieve it from somewhere, and you use this retrieved data to augment a GenAI data model here. Now let's go dig in a little bit deeper. So if you pay close attention to the data results, so you will see that you have not provided any data prompt for me to work with. So as you can see, we made a very, very silly mistake. So we are asking a question, and your prompt expects some data with some retrieved data, but you haven't even provided any. So now it's time to go fix this function called getCompletion. So now let's go back. The whole point is we want to create a RAG function here. So get, as you can see, first of all, we are using a chat function on Ollama, which may not be right. Here I would use another function called generate. So now let's go create another, couple. Now let's go take a minute to what other functions are available. So as you can see, there are two primary functions to work with. One is chat, other is the generate. So generate is when you want to generate some content. When you simply ask a question, hey, what is the capital of USA or India or Mexico, it will return an answer. But if you are trying to create a chat interface, then you should be using the chat chat function on the Ollama interface. So now let's go copy paste this, and here simply what I'm going to do, I'm going to create copy of different functions. So instead of when we want to use the getCompletion, I want to call the generate function, and if you want to say chat kind of a thing, then I'm going to use a chat function on Ollama. Now similarly, one more thing. Now let's go create another function for the code, because code is a little bit different. It's not similar to getCompletion or getChat. So let's go copy paste this, and I'm going to call this function saying getCode. Okay, everything else remains the same, but here are two primary differences. One is we can't use chat, so let's go use the generate method on the getCode function. And second thing is we need to fix the model here. So let's first go fix the model. So instead of calling the model say llama3.2, we want to call it another model, say codellama. You could have called codegemma as well, but let's go with the codellama. And now let's go fix the content here. So here I want to say you are a helpful code assistant, and please answer this question. So you are a helpful code assistant, please. And now let's get rid of the rest of the things here, and it's going to pass the parameter here. All right, so we have defined three functions: getCompletion, getChat, and getCode. One of these is using a chat interface, and other of this is using a generate. And you will see, so a couple of these things, it will fail. But when you are generating a chat, so you pass two different parameters, date and the prompt. When you're simply generating the content, you don't need to pass the two. You only pass the prompt, and it will generate the content here. So as you can see, now we have created three different functions. So I hope you got the idea, what these three functions is going to do. So let's go run this thing and try to run this one at a time. Obviously there will be a lot of mistakes. Please don't get your hope built right now, because I'm intentionally making these mistakes so that you can learn what kind of functions and what kind of method signatures you are dealing with. So let's say code completion, code get code. All right, let me just comment it all this. Okay, now let's go run the get code and prompt. And prompt is here, I just say, hey, generate a function. So let's go write something saying, hey, write a Python function to generate Fibonacci series. All right, so that's good enough. If you run this, it may mistake a mistake. So now let's take a look at the error, what kind of error it's saying. Once you take a very close look, you will immediately see that signature is telling you that client.generate is a good function, but it doesn't understand what message is. So let's go take a look at the function here. Now, if you mouse over this, you will see Ollama.chat. So chat function does understand what message prompt is. But if you go hover over generate, you will see generate, there's no such thing as messages. Instead, it has something called prompt. So let's go get rid of this messages JSON object, whatever we included. And instead, I'm going to replace it by prompt. So again, when you're using generate function, use prompt. When you're using chat function, llama, use messages instead. So let me fix this. I'm going to get rid of these extra curly braces in the bracket. All right, so this looks pretty good now. Now let's go to the other functions. So again, I'm just going to review the three functions what we created. So get completion, one more thing, it does return instead of content, it returns a context string on your response object. All right, so in chat looks good because we are already using the messages here. Now get code, because we are using the generate, so we just can't use messages here. We are going to replace it by prompt. So get completion, let's review it one more time. It looks pretty good. Get chat looks good, get code looks good. Okay, now I'm going to create one more function. So, and we are going to call it a get w code. And let's go try it out with another, say, codellama, because I don't want to use llama 3.2. Again, you can experiment with different kind of code models. Sometimes codegemma or codellama models, it may give you a different result. So, again, please experiment with both of those models and see what works best for you. All right, now let's go generate this one more time. Now, if I run this get code, it will take a couple of seconds before it returns the results. So it did take a couple of seconds, say half a minute, and but it did return a couple of the results. As you can see, it successfully created a Python function which exactly generates this Fibonacci series. So this is exactly what we wanted to achieve that. So just to recap, so far what we have achieved, we have successfully installed Ollama on my machine. So, and we are also running some code generated and some large language models in our machine. Now this is, now let's take it like, let's go focus on what exactly what we want to build. So in our example, we want to use this function to prep the data, but our ultimate goal is to create this kind of UI interface, which I can use to query my online or other PDF documents. For instance, let's take an example. So for example, I have an RPA repository where I have written tons of different codes and online manuals here. And I want to use that content to generate that RAG database what I'm talking about. So simply what I'm going to do, first I want to scrap an online page. So now let's go put this Ollama code function code models what we are running on our machine. Just let's put it to some good use. Here I'm just simply going to ask, hey, help me write a Python function which pulls in the text from a web page. Now let's go run this, and whatever the code comes, I'm going to copy this code, put it here. And as you can, this is complete AI generated code. You can find this code in my GitHub repository, and simply all is saying, go the URL you want to hack. Now I'm going to copy this and put the URL here. And once you run this function, you will simply see the magic that this AI generated code runs without any problem. Again, sometimes it doesn't work, so you have to, put some little bit effort to make it work. But simply what I'm saying, hey, you know what? I can download any text I want from any given web page. So I may have instead of the web pages, I may have some PDFs. So simply change these functions and saying, you know what? Again, I'm using Ollama AI to do the coding for me. I'm going to say, hey, help me write a function which pulls all the URL from a PDF on a web page. So this is the code it generated, and as you can see, this is an AI generated code. You'll find this code into my GitHub repository one more time. Now this is now put the page URL where you want to download all the CSV and those things from. I want to recap that you can also use cursor. If you hit the Control N on cursor, you can also use ChatGPT or other models there. But here I'm using simply because everything is locally hosted. I want to show you that you can use your locally hosted models here. All right, so let's go browse to the one of the repository. So I'm going to go to one of my repository, RPA repository, and here you have seen I have written a couple of the PDF files and CSV files. This is my proprietary data, and I want to create a RAG database on this proprietary data. So I copied that URL and I'm going to paste it here. Now if I run this code, what this code does, it identifies all the PDF files locations on this web page. And you can see where I'm going with this. Once I know the URLs and once I can see the web content here, what I can do, I can download those PDF files automatically here. I want to state a point that once you are working with the AI generated code, sometimes you have to install the external library. All right, so now I think if you run this, as you can see, it was able to successfully locate all the PDF file locations, and it was able to capture those URLs here. If you are interested in CSV, you can run the same code for CSV. As you run this, you will see it identifies all the CSV files located on particular web page which you want to download. Now just to finish off what we started, so the next step is, now I know what the PDF file and CSV file what we want to download. Now let's go write another Python function which helps me download this PDF file one at a time. Now you could have done all of these things in one single function, but I just wanted to showcase, hey, you know what, how to break down your code here. So simply whatever the PDF files we have located, you can just download it. All right, so as you can see, I'm going to give the path to all the individual PDF files what we want to download. So here I'm just hard coding it. You can automate the full thing. It totally depends on your requirement. And I'm going to change the output folder destination. Now let's go copy the location of the PDF files. So here I'm going to say, hey, I want to download these two PDF files, and whatever PDF file I generate, I download, put it into this current folder here. Now let's go run this. All right, so as you can see, it successfully downloads those two PDFs what I just mentioned here. Now let's go just confirm that import os.list directory. So just to showcase that those two files are already downloaded or not. So if you run this successfully, os.list, sorry, it's one word, list underscore dr. No, let me fix it. Okay, all right, here you go. So as you can see, now it has successfully downloaded these two PDFs here. So the whole point is now we have PDF, CSV, all of those sitting in automatically in our local database, and now we are ready to create tokens out of it. So let's go take one more pause and try to understand what we are trying to do. So our ultimate goal is to create different manual tutorial kind of website. So for example, we want to create site for Angular, Oracle, Python, React, and we want to create individual data sets. So we are creating some Stack Overflow kind of a website. So as you can see, for example, one website for Python, one for Oracle. So here again an example. For example, I have got three different giant texts written. So again, I copied this from the Python document tutorial. So for example, there are three different chapters, chapter 3, chapter 4, chapter 5. Now I want to create a RAG which only focuses on Python. Okay, let's solve one problem at a time, and I want to show you that why don't you just directly go and start creating token. So first, just let's go try to read this token into one CSV, and you will see exactly why I'm doing this. So let's just write another function which converts all the txt files into one giant CSV. So again, as you saw, those three files are sitting in some one directory here, and I generated another AI function which reads the content from a directory. So in this case, download.txt, and if I run this, it will create a CSV file, and for each txt file, it could be PDF file. That means each PDF or txt file, I want to put that in a one row in CSV. So let's go run this thing. If you run this, as you can see, it will create a file called scrap.csv. Again, you will find all of this code in my GitHub repository. So as you can see, for each chapter number 3, chapter number 4, chapter number 5, I created one CSV line. Now let's go. You can always double click on this and see what the CSV file looks like. So it looks like this. Obviously, there are three different columns here. Two different columns, and one column has all the giant chapter written in one text. Now instead of now I want to create the tokens out of it. So let's again use our AI code editor to the rescue. And here our ultimate goal is to create the embedding from CSV. But for now, we are just creating the tokens from the given text what we have downloaded. So again, all of the text is sitting in one giant CSV, and there are three different files, one per chapter. So now let's create the tokens from the text. So let's go here again, use our Ollama and just say, hey, help me write a function which create tokens from given text. So which creates tokens. And again, you can use your own tokenizer library. There are hundreds and thousands of them. And please make sure when you're doing that, you may have to pip install your tokenizer here. So, but let's see whatever the CodeLlama model generates it for me. I prefer using that because I want to use everything which is locally hosted. All right, so let's go run this, and whatever the code comes in, and it asks me to install that tick token. So I'm just going to do the pip install tick token and run this library here. But let's take a minute to understand the code. As you can see, it's using a get encoding method called CL100K base, and is reading the text from all the scrap.csv and is going to generate a third column. It's called underscore tokens column. So whatever token this tokenizer is going to generate, I am going to create another column in that data frame, and I'm going to put all those columns inside that. As you can see, this generated this one. So what you will see here, what you will immediately notice that your chapter 1 has 4,216, chapter 2 has 8,000, chapter 3 has 5,690 tokens, which is, so in some cases your chapter could be shorter, your chapter could be long. Obviously, this is the whole reason we are going through this exercise. You do not want to create tokens like that. So whenever you're creating a RAG database, please try to create a token which is uniform. So again, we need to break it out. So we need to create an equal number of tokens from the txt. So again, to the rescue, please use AI again and create another function saying, you know what, help me write a Python function which create equal number of tokens from the list of tokens. So now let's go run this. I may have to restart my kernel here. Let's go redefine the function. Let's go run this again. And whatever the AI generated Python function it generates, let's go try using that. So again, this is the function this AI generated. I'm going to copy paste it here. First thing, as you can see, it allows me to create an equal number of tokens. Here, suppose you want everything a maximum number of 200 tokens. This is something you have to experiment it. So I'm going to create an equal number of 200 tokens from the given number of CSV file or TXT file what we have done. Let's go run this. So as you can see, it's very amazingly fast. So once this is done, now let's go plot this again. Now, as you can see, initially I had only 3 giant rows, but now I have got 94 rows, which has approximately 200 tokens per row. So as you can see, if you do the math, I had 3 rows, and if you add this up, so the equal number of tokens will remain the same. But what I am doing, I am, instead of creating 3 different rows, I'm going to create equal number of tokens, and it will be of 94 rows. And you will see later on videos, once you create your embedding database, why you want to do that. So now we have successfully created an equal number of databases, equal number of tokens from the data what we wanted to create a RAG out of it. That's all I wanted to achieve in this video today. Now next video will be very, very interesting, because when we'll be creating using an embedding model to generate an embedding vector database from these tokens, and we are going to use LLM to run inference on that. So I hope you like this video. There was a lot to cover. Thank you for watching. Stay tuned.